Hello everyone, I'm Sharon and today I'm going to talk about alloying of steels. So what is steel? Steel is an alloy of iron and carbon. How is this steel manufactured? Steel is manufactured from pig iron, which is the raw material needed to make steel. It is crude iron as first obtained from the smelting furnace. It is then processed with coke in the absence of air and limestone or burnt lime which are added to the blast furnace at intervals, making the process continuous. The addition of limestone or burnt lime helps to remove impurities. In order to produce 1 ton of steel, we require approximately 2 tons of pig iron, 1 ton of coke, and half a ton of limestone. So, steels are an alloy of iron and carbon. With less than 2% carbon, it contains iron, carbon, silicon, manganese, sulfur, phosphorus, nickel, and few percent. Steels are classified into two types. The first being the plain carbon steel, which is again subdivided into three types. The first one is a low carbon or mild steel, which has the composition of carbon in the range 0.05 to 0.3%. Second being the medium carbon steel, which has a composition of carbon in the range 0.3 to 0.6%, and high carbon steel, which has the composition of carbon in the range 0.6 to 2%. Next, coming to alloy steels. Alloy steels are again divided into two types. First is the low alloy steel, which is again subdivided into two types. First being the AISI steel, which is American Iron and Steel Institute, and the second being the HSLA steel, that is high strength low alloy steel. Coming to high alloy steels, which is again subdivided into two types, that is tool or die steels and stainless steel. So talking about the plain carbon steel, carbon exists as alloying element here. Other constituents doesn't exceed 0.6% except manganese, that is 1.65%. So the composition of plain carbon steel is, it has 1.5% carbon, 1.65% manganese, silicon, sulfur, nickel, phosphorus 0.4 to 0.6%, and remaining is iron. So the properties of plain carbon steel. It is moderate price steel due to absence of alloys in large amount. It is ductile in nature, soft, it has good machinability, formability. It is available in the form of sheets, strips, bars, tubes. Applications of plain carbon steel. It is used in ball bearings, structural members, housings, and base plates. Under this, we have the low carbon steel. Composition of low carbon steel is, it has 0.05% to 0.25% carbon, up to 0.4% manganese. It is soft and weak. It has good formability and weldability. It cannot be hardened by heat treatment easily. Its strength can be improved by cold working process. It has good ductility. It is least expensive and the microstructure contains ferrite and coarse pearlite. The applications of low carbon steel are, it is used in automobile body, I-beams and channel, tin cans, pipelines and bridges. Now coming to the medium carbon steel. The composition of medium carbon steel is 0.29 to 0.54% carbon with 0.60 to 1.65% manganese. It is stronger than mild steel but less ductile. Its mechanical property can be slightly improved by heat treatment process. It has poor machinability. It's easily welded and forged. So the applications of medium carbon steel are, it is used in railway tracks, wheels of locomotives, gears, crankshafts, forging dies, connecting rods. Next, coming to the high carbon steel. The composition of high carbon steel is, it has 0.55 to 0.95% carbon with 0.30 to 0.90% manganese. Its strength and hardness of steel increases with percent of carbon. Hardest and strongest of all steels, its ductility and machinability is decreased. It is wear resistant. It is capable of holding sharp cutting edge making tools. So the applications of high carbon steel are, it is used in cutting tools, knives, razors, hacksaw blades, springs, punches, and drills. Now coming to the alloy steels. So in order to improve the mechanical property of plain carbon steels, alloys were added. So the addition of alloys was to refine the grain size, to improve its strength, hardness, corrosion resistance, toughness, machinability, cutting ability, wear resistance, electrical and magnetic property. So under alloy steels, we have low alloy with less than 5% of alloy elements and high alloy steels with greater than 5% of alloy elements. So under low alloy steels, we have AISI steels and HSLA steels. So under high alloy steels, we have tool and die steels. These are used for making tools and dies. They have high wear resistance, high hardenability, good wear resistance. So tool steels are classified into 4 types. The first being the cold work tool steels, which are again classified into 4 types. So firstly, the cold work tool steels are used for the cold working of metals. Under this, we have the water hardening, oil hardening, air hardening, and high carbon, high chromium steels. So coming to the hot work tool steels, they are used for the hot working of metals. They are again classified into 3 types, that is chromium tool steels, tungsten and molybdenum tool steels. Coming to the high-speed tool steels, they are divided into 2 types, that is tungsten high-speed tool steels and molybdenum high-speed tool steels. Now coming to the special purpose tool steels, they are again divided into 3 types, that is shock resisting tool steels, carbon tungsten tool steels and mold tool steels. So the various application of these tool steels are, it is used in stamping dies, drawing, forming, piercing, extruding, upsetting, coining operation, thread rolling dies, bush manufacturing dies, punching, drills, forming tools, chisels, hammers, razors, knives, cutting tools, and forging dies. So here you can see the typical compositions of selected high-speed steels with their carbon, chromium, molybdenum, tungsten, and vanadium compositions. So these are the various tool steels. Coming to the stainless steel. Composition of stainless steel is, it has 11.5% or more chromium added to iron. Fine chromium oxide layer is formed on the surface. Steel cannot be stained due to this. So the properties of stainless steel are, it is commercially available in market in cheap cost. It has poor hardness, poor strength, resistance to corrosion, good conductor of heat and electricity, ductile in nature, it has good machinability, it has an attractive appearance and low maintenance cost. Under this we have austenitic stabilizers, which has nickel, manganese, copper and cobalt, and ferritic stabilizers, which has chromium, tungsten, molybdenum, vanadium and silicon. So types of stainless steel, we have austenitic stainless steel, ferritic stainless steel and martensitic stainless steel. So these are the composition of ferritic, martensitic, austenitic, duplex and precipitation hardening. So talking about the austenitic, they are chromium nickel iron alloys with 16 to 26% chromium, 6 to 22% nickel. It has low carbon content with non-magnetic properties. Nickel increases corrosion resistance. Hardenable by cold working, that is worked at low temperatures, as well as tempering, that is heated and then cooled. Coming to martensitic stainless steel. It is chromium iron alloys with 10.5 to 17% chromium and carefully controlled carbon content. Hardenable by quenching and tempering. It has magnetic properties. Commonly used in knives. Martensitic grades are strong and hard, but are brittle and difficult to form and weld. Coming to ferritic stainless steel. They are chromium iron alloys with 17 to 27% chromium and low carbon content with magnetic properties. They are used in cooking utensils, made of this type contain the higher chromium levels. So you can have a view. And these are the austenitic stainless steels and its examples, and ferritic stainless steels. Coming to Maraging steels. So the term Maraging is derived from the strengthening mechanism, which is transforming the alloy to martensite with subsequent age hardening. What is age hardening? It is also called as precipitation hardening. To increase the yield strength of malleable materials. Hardening of a metal which occurs if it is quenched and then stored at ambient temperature or treated with mild heat. Air cooling the alloy to room temperature from about 820 degrees Celsius creates a soft iron nickel martensite which contains molybdenum and cobalt in supersaturated solid solution. So Maraging steel alloys are twice as hard as stainless steel and 35% stronger than the hardest titanium alloy. On the Rockwell scale of hardness, stainless steel is 23 to 26, titanium alloys are 28 to 41, and Maraging steel is 52 to 55. So the composition of Maraging steel. Maraging steel contains an extremely low amount of carbon, that is 0.03% maximum, and a large amount of nickel, that is 17 to 19%, together with lesser amounts of cobalt, that is 8 to 12%, molybdenum 3 to 5%, titanium 0.2 to 1.8%, and aluminium 0.1 to 0.15%. So these are the types of Maraging steels with nickel, cobalt, molybdenum, titanium, aluminium percentage alloy content. So the applications of this Maraging steels are: it is used in aerospace, example undercarriage parts and wing fittings. In tooling and machinery, example extrusion press rams and mandrels in tube production, gears. And it is used in ordnance components and fasteners. Coming to the properties of Maraging steels, it has ultra high strength at room temperature. It has improved brittleness. Simple heat treatment can be done, which results in minimum distortion. It has low carbon content, good cutting ability. It is easily fabricated. It has good quality weldability. It has improved wear and corrosion resistance. So these are about steels, its classifications. Thank you.